I think I'll begin slowly. People will join.
Uh, okay,
Yeah,
sir.
yeah,
Really,
yeah.
so once again, welcome everyone. Uh, Good evening and welcome to day 6 of the IIT JAM Mathematics Workshop. On behalf of the Department of Mathematics, I'm pleased to once again welcome Mandar sir for another session. The last sessions were very engaging and the students also were very responsive and interactive. So, hoping the same for this session today.
Yeah,
Over to you, sir. Thank you so
yeah,
much.
yeah. Thank you, Tina. Even I enjoyed uh, discussing different problems with these students. So let's continue. I'll just share my screen. Yeah, I think it's visible now. Okay, fine. So, hello everybody, everyone. So today what we'll be discussing is differentiability topic and then FTC fundamental theorem, some problems, because if you have seen, I'm sure everybody must have seen the different question papers, earlier years question papers, and there always you can find one question at least on fundamental theorem of calculus and several questions basically on differentiability, say mainly mean value theorems or Taylor's series, etc. So what I'll do, today's plan again is similar. Maybe initial 20-30 minutes maximum we'll have quick revision and certain points we will discuss, and then we will go for problem solving. So then later whole time we will spend on discussing several problems, and maybe during the discussion some more ideas. Okay, fine. So shall we start, everyone?
Yes, sir.
Yeah, yeah. Fine, fine. Okay,
Yes, sir.
yes. So thank you. So let's begin. Again, as a typical start, I would like to take a function, what we did for limits. You know what question am I going to ask? Let me take a point, and somebody can complete the statement. F is differentiable. I'm asking about definition. Definition. F is maybe said to be differentiable at P. If, yeah, just to write. I know everybody knows the statement. So just tell me quickly, someone. F is said to be differentiable at P if,
Limit x tends to p, f of x minus f of p upon x minus c.
right, some typical limit. So the intuitive idea everyone knows, we are trying to talk about the tangent, slope of the tangent at P comma FP on the curve. So whenever such a limit exists, okay, we are going to say that function is differentiable, and then the answer to the limit is nothing but the derivative. We denote it by f dash p. Fine. Then a quick note is differentiability is going to give us continuity of the function automatically, and the converse is not true, and you have examples. Okay, a typical example is mod x. Fine. um so mod x, by the way, is not continuous at I mean not differentiable at,
0.
right? And what about other points, like if I ask mod x, derivative of mod x at say 3,
1.
understand? So this function is not so bad. I mean, it's just not differentiable only at one point. Everywhere else it is very much differentiable. But then using this, can we now create a function which is not differentiable exactly at 2 points? Any function?
Mod x minus 2 plus mod x minus 1.
Very nice, Tanya. Mod x minus 1 plus, sorry, I mean, of course, plus 2 also will work, but I'm just writing for example. And this is typically not differentiable at 1 as well as 2, and everywhere else it is differentiable. In fact, between 1 and 2, it is expected to be, I think, constant. Okay, that also can be seen. Good. And now if somebody says, somebody asks me, give me a function which is not differentiable at some n given points, we know how to construct it, right? And this question can be asked further, like what about if I have some countably many points, infinite countably many points? What happens if I have uncountably many points, infinite, and so on? So anyway, that I'm not getting into right now. So this is fine. I'm happy people knows this. Just moving further, we would like to talk about something like higher order derivatives. Higher order derivatives. Okay, which you know that if a function is differentiable once, I get I mean at different points in the domain or maybe over the domain, then we can even talk about a new function f dash, which is from the same domain to R, and ask about this function whether this is differentiable. If that is also differentiable, we can ask about, I mean, we can talk about f dash ka derivative, that is f double dash, and so on. Now again, a typical question one should ask is, can it happen that a function has f dash existing, but f double dash does not exist? So it is differentiable once, but not twice. I'm sure people have worked out an example.
No,
Yes,
sir.
sir. Yes,
Yeah,
sir.
yes. So can you just quickly give me the example?
Yes, sir. X square sine 1 upon x when x not equal to 0 and 0
Ah,
when x equal to 0.
yes. There is something coming into discussion. So sine 1 by x is coming into picture, and 0. So this is when x is non-zero, which is correct, and 0 when x is 0. Uh, Now why this is differentiable? One can actually see the derivative actually at 0. By the way, what about at every other point? I have to specify the point also where this happens. This doesn't happen everywhere. Okay, what about other than 0? If I ask at 1 what is the situation, then both are existing, f dash as well as f double dash. So just to be precise, I can just say at 0, this function fx equal to so and so. I look at it at 0, then yes, f dash is existing, f double dash is not existing, right? In fact, easy. If I want to confirm f double dash doesn't exist, what I have to do, by the way? How to prove f double dash doesn't exist for this function? F double dash at 0.
We have to
Sir,
show that it does not exist.
Sorry, we have to show that.
sir,
Limit does not exist.
we have to show
Ah,
that f dash doesn't continuous.
f dash is not continuous. You would like to show that f dash is not continuous at,
0.
okay, you expect that it's not continuous at 0.
Yes, sir.
Okay, yeah,
Yeah.
fine, fine. Let's play with it a bit. Let's spend some time because there will be some questions on this. So fx, I'm writing it again, x square sine 1 by x and 0. X not equal to 0. Even others can stop me, or if you feel this is obvious, you can even say that. It's fine. Okay. Yeah, I'm keen to talk about f dash. Okay. And I'm keen to f dash at 0. And I'm actually keen to talk about f double dash at 0 also. So to talk about f dash 0, life is easy. You just have to compute, you just have to look at this limit x goes to 0, fx, that is x square into sine 1 by x, minus f of 0, but that is 0 upon x. That is x, and x is gone. So x sine 1 by x is a very famous limit, which we know it is 0. Okay, by sandwich theorem or something, it can be proved that x sine 1 by x goes to 0. This is okay to all. You can ask me if you are not okay with it. I hope this is typical example. Everyone knows. Now, how do I talk about f double dash 0? It is actually to be, but to go ahead, it is limit x goes to 0, f dash at x minus f dash at 0, but f dash 0 is 0 upon x. Now, what do I write? Hmm? I need expression for f dash x. Do you understand?
Yes, sir.
Yeah. So, how do I get it? F dash x u
That
into v, right?
Yes, sir.
Because other than 0, this is well behaving. Means there is no issue as such. At 0, f dash 0, we have to compute separately. And you got it as 0. So at x equal to 0, we know the answer. F dash 0 is 0. F dash x u into v. So it is, say, if I am talking about x square as it is, sine 1 by x, the derivative is cos 1 by x into derivative of 1 by x. That is 1 by x square. Plus sine 1 by x is as it is, and the derivative of x square is 2x. Now, when you look at the first term, you are left with cos 1 by x plus x sine 1 by 2x sine 1 by x is not going to trouble much. 2x sine 1 by x. Kavyashri, just can you mute yourself? So 2x sine 1 by x has no problem. This is going to be continuous. I mean, this is going to be 0 as x tends to 0. But this won't exist. So as I forgot the name, someone said, we have to show that function is not continuous at 0, f dash. And that's going to happen because limit x tends to 0 of f dash x does not exist. Okay. And so continuity fails. And that is enough to conclude that f double dash at 0 won't exist. This is fine. So this is how one can go for it. Fine. So this is one example I wanted to say. And now if somebody says that instead of, if I want a double derivative exists but triple derivative doesn't exist, you just have to keep increasing the powers. So I'll work with x cube sine 1 by x. Then I can go up to f double dash, triple dash won't exist, and so on. Fine. Is there any other example? F dash exists, f double dash not exists. Other than this, anyone? F dash exists, but f double dash does not. Any other example? Oh, come on.
Uh, so
log x.
it's x mod x.
Ha. Something like that is coming. That is x mod x. So, okay, I don't need curly bracket as such to begin with, but now I can put a curly bracket because mod x is x. So I get x square when x is bigger or equal to 0 and minus x square when x is less than 0. Right? So this is differentiable. By the way, point is at 0 again. So this is differentiable once at 0, and the derivative will turn out to be something like 2 mod x, 2x and minus 2x. This is how the derivative f dash x will behave like. And now when you try to look at f double dash at 0, it won't exist. It is behaving, it's actually mod x, 2 mod x basically. So it won't work. Fine. In fact, yeah, now I should ask one more. I'm So this is correct. And you can produce more generally, suppose double derivative exists, triple should not. Then x square mod x, x cube mod x, and so on. Anything else which we can cook for the same? One more, just one more. F dash exists, F double dash doesn't exist. दो ही है. Come on, I mean, I'm sure you can cook one more example, but stick hai. I mean, let us not get into much of it, but I just wanted to show you, say maybe x square and 0. What will happen to the derivative? It will be something like 2x and 0. And now 2x and 0, the graph will be like this, straight line, 0 for x positive. This is greater than or equal to, and this is x less than. So for negative side, it is 0. And suppose this is my y-axis, x-axis. And then this is 2x. So you can see at 0, there will be a corner. And so it won't be differentiable. So this is f dash. And this is my f. So again, this is another. And now you can construct several such examples. Fine. So I can move fast to the next. So what I mainly concentrate on is the mean value theorems. So to begin with is Rolle's theorem. Okay, which again people know it. So I write quick statement of it. You take a function from AB to R. What are the conditions needed? F continuous on on closed interval and differentiable on open interval. And what else?
F of A equals to F of B.
F of A equal to F of B. People know the geometry. I hope that what is happening with the function on the graph is, this is A and B. You have F of A and F of B taking same height. Now, however the function behaves, it's continuous and in between differentiable also. So whichever way it goes, you can see that there is going to be a point, because it has to come back to the same height. So there will be a point where the tangent is going to be parallel to x-axis. And so slope of this tangent is expected to be 0. Okay, and that's what you are trying to say. So there exists some C between AB such that f dash C is 0. Okay, this is what Rolle's theorem is. Just to take a pause and ask one question, which I always ask, that is, when we say differentiability, why are we, means, why we are taking open interval? Like, why can't we take even differentiability on closed? I mean, is there any function which is differentiable on open but not differentiable on closed?
Because sir, at endpoints we can make infinite number of tangents. So
Okay,
it won't be.
see, understand, differentiability at endpoints, how it is defined, by the way, of a interval. So differentiability is defined in terms of either right side derivative or left side derivative. That way we can take it.
Sir, tan x between -5/2 plus 5.
Ashutosh, you get my
Tan x
point?
correct.
Is my question clear? So you won't get infinite tangents. See, for example, at this point I'm talking about, then I will talk about left side derivative only, because right side derivative is out of question. It's not that I can draw such a tangent, not like that. That won't be defined. So when you want to talk about differentiability at this end point B, you will only talk about the tangent existence of such a tangent, means tangent to the curve from here. Got it? That's the definition. So my question, simple question is there a function? Is there a function differentiable on open interval, continuous on closed interval, but not differentiable on closed interval. If such a thing is happening, then only, I mean, then this makes some sense, because we are trying to cover such functions as well. Otherwise, if there is no such function is existing, we could have very much taken closed AB. How does that matter? I hope you are getting my point. So, is there such function existing?
Tan x.
Sorry, Tanya, I'm sorry, I didn't get you.
Tan x on minus
Tan,
pi by 2 to pi by 2.
okay, you mean tan x on minus pi by 2 to pi by 2, but problem is I want it to be different, continuous on closed, you know, so that won't work, na?
Sir,
Huh.
sir, f of x equal to mod x आपण घेतो ना मग we can take that interval as close 0 and open infinity.
Yeah, if I take it as close 0 to
Anything, I mean, open
2,
infinity.
in I want a finite length interval,
Okay,
say maybe
anything to
0 to 2, fine, but then the uh, interesting point is, if you are not including the neighborhood for this, neighborhood of 0 is not included, then this will behave like fx equal to x, you understand?
yes,
So it won't cause any trouble at for the differentiability at 0. Get it?
yes,
This is
sir,
the
got it.
point. I said that endpoints differentiability is defined through right side derivative or left side. So this won't work. Hmm. See, what you are thinking of is correct, line of thinking, that you want to, at end point, there should be a problem. The tangent should not be existing. Or the tangent can be parallel to y-axis. That's a hint. Do you have any such curve whose tangent is parallel to y-axis at some point?
1 upon x.
Okay, 1 upon x at which point?
0, 1.
But then close 0, 1 you can't talk about, because at 0 it's not defined, and you want close 0, 1 continuity on close 0, 1. You know? So this is
Sir, x cube.
okay. X cube. X cube is well behaving. It's differentiable everywhere. So I want non-differentiability at closed AB on closed A. Means at A and at B, it should not be differentiable. Between A and B, it should be differentiable. And I know in 12th you must have studied this function without noticing it much. So let me ask, in 12th, have you calculated derivative of this? Chain rule, वगैरह, typical exercise. So what did we do? Derivative of this कैसे निकाला था हमने? वो ऐसा dy by dx, है ना? 1 by root x का derivative 1 by 2 root x, right? And then into derivative of this, that is minus 2x. So 2 will get cancelled out, and you are remaining with minus x upon, ऐसा निकाला था, we have, is this fine? But now what happens to the derivative of this at say 1? Derivative of this function at 1.
Does
It is
not
not existing.
Exist.
And even at -1, it won't exist. But how about continuity of this function at 1 and -1? Very much there.
It's
So
continuous.
what I'll do is I will take fx as this on -1, 1. And exactly what we want is happening to this function. It's basically half circle. You can now understand what we are trying to do. So it's actually a half circle graph. And now at this point, if you see the tangent, it will be this line parallel to y-axis. And hence its slope is infinite. And so in that sense, the derivative won't exist. Got it? So understand, my point is this: when any theorem gets developed, it tries to cover maximum, means you can't further expand it. Now this many minimum required conditions are there, and that will guarantee the conclusion. So you can't now uh, expand it further and try to include some more functions. Like if I now say that, okay, continuity also let us compromise and have it on open AB only, then the conclusion may not hold. You understand my subtle point that I wanted to tell you? So any result, any theorem, when it gets evolved, when it gets developed, uh, you have to think about why such conditions only are there. Okay, that is how one can uh, develop the insights. Fine. So shall we go ahead? This is, I hope this point is getting conveyed. So that's Rolle's theorem. I'm moving fast to LMVT, a very famous mean value theorem, Lagrange by Lagrange. And I'll not now write anything. I'll just draw a figure. You have point A, whose image is f of A, and you have another point, that is B, whose image is somewhere here, maybe f of B. And I have this line. Okay, what is the slope of this straight line? We can compute, because this is BFB and this is AFA. So we can get the slope of the line. Now you take any function, okay, which is continuous and differentiable in between open AB. Then you can always find some point where the tangent to that point is parallel to this line, and hence the slope of that tangent. So this is the point C, and what you get is f dash C. The slope of the tangent is same as slope of this line, that is fb minus fa upon b minus a. Everyone, I hope, knows this geometry. I'm just mentioning it somewhere. Fine. So this is what LMVT is, and it's a powerful tool. We'll see how it can be used, interestingly. To move further, I just want to say, if we apply it to, instead of a to b, if I apply it to the interval a to x, what I get is f dash c equal to, where c lies between a and x, equal to fx minus fa upon x minus a. That is, we can take it to the other side and we can write f of x as f of a plus x minus a into f dash c. Now you can see that this is nothing but Taylor's expansion for degree 1. Okay, so basically that is the, I mean, lowest version that you can have. LMVT provides you actually Taylor's version, Taylor's theorem for degree 1. I mean, first order derivative, order 1, I'm sorry, not degree, first order. Okay, so that is one quick observation that I wanted to do about LMVT. Now moving fast to, since I mentioned Taylor's theorem, okay, I can just mention the final statement. Okay, so Taylor's theorem, basically what is the purpose? What is the use of Taylor's theorem? Any because I know everybody knows the statement. Okay, what you are trying to do by Taylor's theorem statement, what we are actually trying to develop one
Ex-
angle,
func- Expansion of function.
expansion of function, right?
Uh, Sir, approximation of differentiable function through
Okay,
polynomial.
right. You would like to approximate it. Why do you want to approximate? You know the function, right?
To get the error.
To get the error, okay. Which error? But hmm, error in what? Uh, See, yeah, I'll just mention that if we know, if we don't know the function, but if we know the value of the function and its derivatives at some point, say maybe one, or in general I can say a, f dash a, we know this, f double dash a, okay, say maybe something like distance, velocity, acceleration, something like that. So if I have some observations, physical observations, which gives me the values of these expressions, so I know f of a, f dash a. So at one point, at some time t, if we have collected this information, and I want to retrieve the original function, what it could be. I want to know what is f of x. Then Taylor's result helps. Okay, so as somebody said, so we can actually get the expression for fx without knowing full function f of x at any x. Of course, there are limitations, and certainly, as he said, error is involved in this calculation, right? So, but then if I know these four terms, I can try to get something like this kind of a expression: x minus a into f dash a, x minus a square by 2 factorial f double dash a, x minus a cube by 3 factorial f triple dash a, and one can continue actually. Now, when I say continue, there are several questions. That is dot 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 means what? So we are talking about infinite series. So this is called as Taylor's series for a function. But then when I talk about series, there is a question of convergence, right? And so, I mean, yes, we may not be able to get a series expansion for every given x, but at least in some neighborhood of the point A, we will be able to get f of x expression in terms of a series. Okay, that's what Taylor's theorem says. So there are some conditions. Now, if somebody says that no, 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 I don't want to work with series because practically I don't have the data. I have the data up to certain derivatives. So in that case, you have to truncate, and when you truncate, when you go up to certain derivative, the remaining terms, there is a error involved. So we would like to, then there are people, I mean, there are uh, mm, uh, uh, expressions for the remainder term, which represents basically the adjustment of the error. Okay, so when you want to write equal to, ideally it is infinite series, but if you want to stop somewhere, the last term has to consider the all the error that may get involved, and that is called as the remainder term, Rn, or sometimes, so there are different forms of the remainder terms. Let us not get into that. So this is the idea of Taylor's theorem, which we will see. Now I think I'm too much. Let's quickly move. So fundamental theorem, will when we actually get into, we will see. So let me share my link to the to the problem sheet with you all. Let's.
Sir,
Yeah, yes, Ronak, tell me.
you can use Taylor's theorem for finding roots of the function also, right?
Finding roots of the function. How it can be used?
The
Yes.
approximate roots.
Approximate roots. Okay. How do you do that? Taylor's theorem का expression use करके roots of fx you win. I'm not sure about it. What is the idea of getting it? Like when you say fx equal to 0, you want to capture such x. Maybe I will check it out if you think so. Any others also can throw some light on it if they know such method. I'll also check. Right now, I'm not sure whether it is used for getting the roots of a function. Fine. Yeah, shall we go for some problems now? Could you see the sheet, problem sheet?
Yes, sir.
Okay. So just go through and we can start from the first simplest to begin with. I'll also try to get the question sheet now. Let me. Yeah, I think this is the first page. Okay. Let's look at first question itself. This is, we can go fast. It's very simple, easy question, but just to, what do you do, by the way? Can someone tell me? A question, how do you handle it? Simply. Huh?
Graphically.
Very good. Just draw a graph and you are done. Okay. So how do you get mod x minus 1 ka graph? Again, that is easy. You have mod x like this. Sorry, my line is problematic. So this is mod x. So when you say minus 1, this part will come down by 1 unit. So mod x minus 1 will be something like this. Okay, this is minus 1 and 1. Okay, but this portion is there only when mod x is bigger than 1. Matlab this part only. So we have to remove this portion. This is not the part of the graph. And over minus 1 to 1, mod x less or equal to 1, it's just 0. So it is this. So this is the graph, and I'm sure you know what is happening. What is the answer finally?
B.
No, f is differentiable.
A.
Huh,
It's
fine. F is differentiable at, so at 0 and at minus 1 and 1, it's not. That's it. Okay, good. ठीक है. Move ahead. Those who are done can. Yeah, second also I would like to talk about, just to get some grip on definition. So look at second. स्ट्रेटेजी क्या होगा बोलो कोई तो, जैसा पहला आप ग्राफ बोला वैसा व्हाट विल यू डू?
Sir,
Limit at 0 should be equal.
Sorry, at zero. Tanya, can you repeat?
Limit should be 0. Both side limits we should check
Correct,
at 0.
correct. That is, you are talking about continuity of the function. It's differentiable, then it should be continuous. Correct. Yeah, and Sunil was saying, or someone.
yes, sir. I also saying that
Ha.
continuity.
Correct. So first, by the way, there are two unknowns. So naturally, what you expect is two kind of equations which will give us the values of two unknowns. So do it. 30 seconds. So look at limit x goes to 0 from negative of fx. Now how to handle this, by the way? This is 0 by 0. L'Hopital.
Yes, sir.
Hmm. So a cos x minus 2 divided by just 1. So that is a minus 2. And the limit x goes to 0 plus of fx. But that is simply 0. Hence, you want a minus 2 to be 0. So a is 2. Now derivative. A, you know it already, it's 2. So 2 sin x minus 2x. So your fx now is 2 sin x minus, sorry, 2x on x and bx. Now derivative at 0. So you want to talk about limit x goes to 0 minus of fx minus f0. Now what is f0? F0 is 0 upon x. So you want to talk about limit x goes to 0 minus of 2 sin x minus 2x upon x square. So calculate. I'm not doing it. The other one is limit x goes to 0 from positive side fx upon x. Anybody got the answer? Oh, something in the chat I forgot to see. Okay. Itvi has
0.
Sorry, answer to this limit is 0.
Yes,
Yes,
sir.
sir.
Okay. So then a plus b, the value is
2.
2.
2, because a is 2 and b is 0. Fine. Any other answer? Anyone has objection? Means I have not calculated. I'm just relying on you. Okay, but I'm sure you can do it. Let's move ahead. No, move ahead further. Say third, fourth. I think we have enough discussion. Uh, Fifth, we can try quickly. So let me pick up fifth question. This requires some work. So I'll take some 30 seconds pause. You all think on it. Yeah, anyone got any idea? What will you do, you tell me, to handle the question? हाँ? कहाँ से स्टार्ट करेंगे इसके साथ काम करने को?
Begin with x minus t का graph.
Okay. Okay. See, yes, I mean, you can try that. But my point is, when you say mod x minus t, it has some understanding. What that understanding is, it represents distance, basically. So what we are trying to do is we are trying to look at all possible distances of x from everybody from our set, and then trying to take the kind of largest, so supremo of all possible distances of x from everybody from the set. So obvious starting point could be take some set, just to play with quickly. Take some set, say 2 to 4, if I am taking as my set interval. What will happen to f of 7? So distance of 7 from everyone, and then what is the largest one? Can you guess?
5.
Okay, 7 is here somewhere. This is distance from every point of A, and we want the supremum of that. So is it 5?
Yes, sir.
Yes,
Correct.
sir.
7 minus 2. Very good. Thank you. Whereas if I ask what is f of 0,
4.
4.
4. Very good. If I ask f of 2,
0.
2.
2.
f
No.
of 2. So distance of 2 from everybody in A and then the supremum.
Yes.
So it
So
will be 2, correct. F of 3,
1.
1.
1.
1.
1. Ah. Are you getting the idea? 3.5
1.
1.5.
means you are trying to look for 3.5 and 2 ka distance. You are going to the other end. So exactly how this function is behaving is you look at 3. So if x is less than 3, less than or equal to, you can say, then you are, so this is 3 and this is 2 to 4. You are, agar, if you are here somewhere, you will look at its distance from 4. So basically it is mod x minus 4. And if the number is here somewhere, that is x bigger than 3, 3 onwards, then you look at its distance from 2, right? Mod x minus 2. You understand this?
Yes.
Now
Yes,
what
sir.
now can you answer this question? At least for this function. Then we will see whether it is can be generalized.
3.
Not differentiable at 4 and 2.
At 4 and 2. Okay. Why so?
Not differentiable at 3.
Ah, just at 3. See, I got why you are guessing it as 2 and 4 because it is x minus 2 mod. But you know, it is out of the, means this condition doesn't contain 2. Understood? So we
Yes,
are
sir. Yes.
safe. So we are safe. At 2 and 4, there is no harm. But at 3, there is a issue. Continuity is available, but there will be a corner. Your function's graph will be something like this. Okay. And so at 3, you won't be getting the differentiability. And only at 3. Only at 3. Now, question is this scenario in general is also available?
Sir, can you extend that again? Why it is not at
3?
yes, sir.
I'll explain. See, when you say, for example, when you look for f of 4, so f of 4, if I want to get, it is distance of 4 from 2. So that is going to be 2. So f of 4 will be 2. Same thing, f of 2 will be also 2. Right? F of 2 is also going to be 2. We already discussed that. F of 3, okay, no, it's not 0. It will be upside. So f of 3 is 1. That means the same diagram, but lifted 1 unit up. So let me just do that correction. Okay, Aradhana has answered the question correctly. Thank you. I'll just make this correction that I may not have it 0. I'll be having it as, say, in this case, it is 1. Okay. At 3, it is 1. And same thing then. So this is how it will go. No? It is straight line up to 3. Fine. And after 3, it is another straight line. In fact, I don't have to take mod x minus 4. I know what is the positive value. So when x is less or equal to 3, it is 4 minus x. So in fact, I don't have to write it in terms of mod also because it is confusing. So let me write simply 4 minus x. Right? Whenever x is here, it is its distance from 4, that is 4 minus x. And this also can be written in a simpler manner. So x is greater than 3 means whenever you are here, x minus 2. Simply. Okay, and so these lines, if you draw, you will see that at this there will be a corner. So at 3 there is a problem. Now, yes, I want the last remark, means finally, can I generalize this to any set, non-empty bounded set? And say B is true. I mean, B is the correct option. Continuity is available, differentiability not there exactly at one point. And which is that point? Can you say in general? किस point पे differentiability नहीं मिलेगी?
Midpoint
Yes, midpoint of
interval.
interval. Which interval? Because my set A may not be an interval. A is just any non-empty bounded set. That's
The
it.
set, the
No,
given
you're given any set. Your voice is cracking, Komal.
सर यूनियन ऑफ इंटरवल लेने पर भी ऐसे ही बिहेव करेगा.
point of
हाँ.
given set, I was saying.
I didn't. Yeah, Aradhana also is writing midpoint of distance, but which distance? Yes, midpoint of something that everybody got. Yeah, even union of open sets is fine. Means जब तक वो bounded है और non-empty है, there is no issue. But I need not take open intervals also. I may take something like this 2, 3, 7 finite set union some open interval 9 and 10 union some 1 by n whatever. I mean, I can just take some randomly a जब तक वो नॉन एम्प्टी है और बाउंडेड है इट्स फाइन आई कैन टेक एनी सेट ए नाउ हाउ डू यू गेट द this point at which point it's not differentiable huh
Sir, that time I was trying to tell about the midpoint of the given set.
but what do you mean by midpoint of a given set because this is the set then what is the midpoint of this set how do you decide the midpoint of a set such a concept is not there na you are correct means intuitively what you do what is special about 3 basically it is see here this 4 and this 2 what are these two real numbers they are basically supremum and infimum you get it so actually it is supremum minus x and x minus infimum where x is changing its behavior exactly at the midpoint of the interval from infimum to supremum basically so this 3 is actually supremum plus infimum by 2 the arithmetic mean of supremum of A and infimum of A, which very much exists because A is bounded and non-empty. So we can not only say it's not differentiable, but we can even say at which point at supremum of A plus infimum of A upon 2. At this point, it won't be differentiable. Okay. I hope it's clear to everyone. And see, my suggestion is even if totally it's not clear, you can later on even work out with some example, it will be clear. Hmm. Since I want to cover more problems, I'm in a little hurry, but of course you can stop me. This is fine. Shall we go ahead?
Yes, sir.
No, fine. So sixth is okay. Can you do it? Then I'll not discuss. Sixth one.
Yes, sir.
Okay. So sixth one, it is just an exercise on derivative of composite and inverse derivative of in. I can skip. Even seventh, you can quickly answer. Means we don't have to 7 doesn't require any working. Can someone answer 7th?
So it's D.
It's D, correct. And now can you just throw the light, like one line about the
Yes,
function?
sir.
Huh.
F is constant.
Bus, that's the point. So this condition fx minus fy, I'll just tell this for others. Sunil can go to the next question in the sheet. So this condition, what does it says? X minus y raised to 3 by 2. What I will do is I will write here 1 by 2 and here mod x minus y in the denominator. Okay. Now this suggests, so I get something like mod fx minus fy upon x minus y, which is nothing but the expression needed for the derivative of the function at say x less or equal to 5 into mod x minus y raised to half. Now something like if I am talking about limit y tends to x, then this is nothing but f dash x. Okay, but where does this will go? This will go to 0, and hence we expect that f dash x is 0 for all x belongs to R. But that tells me f is constant. But we already are given the constant. F of 2 is 2. That means f of x is 2 for all x. Once this is known, it is just u into v that you have to apply and do computations. I think you can do that. And Sunil's answer is correct. That is 24. Okay. This is again a famous, condition. All right. So whenever such a thing is available, let me say more generally, fx minus fy less than or equal to some constant times mod x minus y raised to alpha, where alpha is greater than 1, will imply f constant. You get my point? Whenever this alpha is bigger than 1, you can take 1 mod x minus y down and do the same argument. Okay, so this you can see such question is asked at several question papers. Such a condition is favorite condition maybe. Hmm. Is it okay to all? Okay,
Yes,
Aradhana has given the answer, correct. I'm moving ahead to say, yeah, next one I would like to discuss. Uh, Eighth one. Okay, now how do we deal with it? How to deal with it? See, for discussing f double dash 1, you need to first know f dash at 1. Understand? Because f double dash 1 is f dash x minus f dash 1 upon x minus 1. Okay, I want to talk about f double dash 1, but that is limit. Say x tends to 1 of f double, f dash at x minus f dash at 1 upon x minus 1. This is f double dash. But for that, I need to know f dash at 1 at least. But what is f dash 1? Limit x goes to 1, f of x minus f of 1 upon x minus 1. Now, do I know f of 1? How do I get f of 1? Now, who can tell me f of 1 from the condition? Hmm. Okay, someone has posted. Yeah, Aradhana, correct. F of 1 is 1 because sequential continuity we have already understood. So this is my sequence xn, which is converging to 1. Then f of xn ideally should converge to f of 1 because continuity, your function is differentiable, so it's continuous in particular at 1. But f of xn is 1 constant. That means f of 1 is equal to 1. Okay, so f of 1 is 1. First thing is done. Now, how do we get this limit? We do not know f of x, but we know value of the function at some points near 1. That is enough. You understand? Because whenever limit exists, we can take it as limit along any sequence. So this is f of xn minus f of 1, that is 1 upon xn minus 1. You agree to this? Whenever main limit exists, it can be written as a limit along any sequence. This is fine? Yeah, correct, Aradhana. So f of xn, but f of xn is 1. So this is 1 minus 1, numerator is 0. That means limit of 0 you are talking about, which is going to be 0. So f dash 1 is 0. And now, how do I talk about this now? So this is 0 anyways. So I want to talk about limit x tends to 1 f dash x upon x minus 1. Now problem is we have no information about f dash other than its value at 1. That's it. So what to do? Mhm. हिंट दूं के आंसर दूं के कुछ भी नहीं दूं?
Sir, can't we do the same here also?
मीन्स व्हाट? सी यहाँ पर कर पाए बिकॉज वी वेर नोइंग एफ ऑफ एक्स एन एटलीस्ट. यहाँ पर एफ डैश एक्स एन का भी पता नहीं ना. यू डोंट नो एफ डैश at any point. Here we were knowing f of xn, so we could survive. So if you know f dash at some sequence converging to 1, then it is okay. So can you know the value of f dash at some sequence converging to 1? F double dash 1 is by observing Taylor's expansion. Okay, you are trying to observe Taylor's expansion. Okay. So how do you observe it? Of Taylor's expansion of the function fx? About 1, you are saying? Yes, your answer is fx around x equal to 1, which is okay. So if you write something like f of x is equal to f of 1 plus x minus 1 f dash 1 by 1 factorial x minus 1 square f double dash 1 by 2 factorial plus and so on. Fine. Now what will you do? How does this conclude? This gives us f double dash 1 is 0. Okay, if subsequence converge to 1, then fx should be convergent. Yeah, I didn't get the statement. Mm, yeah. Let me disclose Aradhana's answer is correct. Only I am not convinced with the uh, argument. Okay, I'll go a little fast. See, understand what we know is f of xn is 1 for each n, and xn is a typical sequence. You get my point? Xn is what? So this is 1, suppose. Then xn is 1, n equal to 1, that means 2. This is x1, x2, x3, x4, and at all these points function is 1 constant. Function is constant 1 at these points. All right, but the function is non-constant, by the way. All right, so can we not apply some theorem? Just now we saw Rolle's theorem. See, because I want some information about f dash, isn't it? So that I can catch up only when somehow I can get some result which relates the value of the function with its derivative, and that is Rolle's theorem, one of the theorem. So what I know, f of xn is f of x n plus 1. So between xn and xn plus 1, there has to be something where f dash will vanish. So there exists some yn between x n plus 1 and xn. such that f dash at yn is 0. Okay. And now where yn will converge? Because xn and xn plus 1 both sequences are converging to 1, yn has no choice. By sandwich, yn has to converge to 1. So I can talk about this again as limit n tend to infinity f dash yn upon yn minus 1. And this is 0 because f dash yn is 0. So that's the argument. So somewhere, by the way, this function behaves like that sine 1 by x cos 1 by x kind of. Okay, it may go like this, then go down through this point. At all these points, it's 1. So it's kind of such a oscillating kind of a function. Okay. So at these points, you get f dash 0. Okay, fine. So this is one thing I wanted to discuss. I hope this is clear. Shall we go ahead?
सर
Yes. Who is this?
सर इसको टेलर सीरीज से नहीं कर सकते जैसे एक फंक्शन एज्यूम करके 3 टाइम डिफरेंशिएबल पॉलिनोमियल फंक्शन
हाँ, ओके. तो आप थर्ड डिग्री तक जाओगे. x minus 1 cube upon 3 factorial and f triple dash at some theta, means you will have to take f triple dash at some c. यहां तक लिख सकते हैं, लेकिन आगे क्या करेंगे? हाँ,
x replaced 1 upon n then some sequence like 1 upon n type.
so x we replace it by 1 plus 1 by n.
Yes sir.
हाँ, okay. So one has to work out. I am not sure whether this will. If this gives, it's fine. Means I'm not, you can work it out actually
Okay
to
sir.
see whether it works. Because it is given 3 times differentiable, we may intend to try out that. Actually, in my argument, where I'm not using third derivative as such, and I don't think it's needed. Maybe it is just given for so as a extra extra information, but one can try. So tailors, you can just try and see whether it works. Huh?
Okay sir.
Fine. Yeah. So let's make a move to next question. So let us not now get into 9. I hope is even. 10 also is standard. If function is even, then its derivative is odd and so on. So that can be skipped. Can you see 11th question? I will not discuss. You just tell me what to apply to 11th question. That is enough. So question number 11 I want to talk about. Yeah, this is. So just tell me what will you apply?
Sir, draw the
Ah,
curve at given points, then apply Rolle's theorem.
right. Rolls or mean value means Lagrange.
Yes, sir.
Yeah, correct. So try Lagrange mean value theorem and one should get the idea. Okay. So that is enough. I don't think we have to keep discussing further. So this can be handled. Okay. Simply apply LMBT. To whichever interval is helpful. ये करके देखना पड़ेगा, but आ जाएगा. I hope. So let's make a move to 12th one. This is LMBT. Apply. This one
सर ये भी हो जाएगा इसमें जस्ट
standard, very good. Yes, yes. So simply Taylor's coefficients, you know the formula, and you can fx. So simply compute and you will get alpha. So that you can manage. Even if you see 13th, it is actually L'Hopital's. So you have to have, I mean, of course, raise to x, how to convert it into, and then use log and then L'Hopital and go ahead. So this is also
यस सर
working काम है, but आ जाएगा. I hope you can handle this. हाँ? So let's look at, say, directly, let's take a jump to 15, 16. So let's look at this. Yeah, let's see these two first, then we'll make a move to further. Even 15th is easy, I think. Okay, 15, hit, we got the answer. It's B.
यस सर
Huh, good. Alpha, beta, yes. Hmm. Huh, yes. Any comment?
नो सर
Huh, fine. So 15B, if anyone has a question, can ask, else we'll go ahead. So x into root mod x. Hmm. So if you look at first thing, f of minus x is minus x into root of mod x simply. So that is minus of fx.
सर 15th
Ah,
में सर
sorry.
15th में ए क्यों नहीं हो सकता
Yeah, I don't know, miss. I just realized that's what. So should I
ओके
work it out once?
अब
Uh,
सर
huh.
क्योंकि एफ ओके एफ डैश वन इक्वल्स टू 0 और 5 डैश इंक्रीजिंग
Okay, let me check it out. I didn't check that. So I'll work it out.
सर 5 हो जाएगा 1 1 फंक्शन बिकॉज स्ट्रिक्टली इंक्रीजिंग
Yes.
and then an interval is given 2 to 3 close and bounded and then
No,
supremum and
phi
infimum
dash is
attains
increasing. Phi dash is increasing. Okay. So phi is 1 1, you mean? Yeah, phi dash at 1 is 0. So definitely phi dash, phi dash at 2 will be greater than 0. In fact, phi dash at x will be greater than 0 for all x in 2 to 3. Now we can say phi is increasing. So phi is increasing. And so,
yes sir and interval is given that close and bounded then it's
so
supremum attains at 3
supremum is attained at 3. Correct. Maximum is at 3, minimum is at, so that's correct.
then beta is phi 3
So I just relied on the answer that is given. Correct. So this is the answer. Beta is equal to phi of 3 because phi is increasing in the interval 2 to 3. Yes, yes, correct. Good. Fine, fine. No problem. Thank you, Sunil. Okay. Can I just erase this and move to this one? Yeah. So, a quick observation I'm just trying to make is f is odd. So, enough to know the behavior of this function to the positive side to begin with. So, when x is positive, it behaves like x root x. So, what do you think is going to happen to this function? Hmm. See, if at all it has a problem, it can have a problem only at 0. It's differentiable everywhere else is very clear, I hope. So at 0 you check. Okay, one answer has come in the chat. Okay, f is differentiable at all points and f dash is continuous, you would like to say, Aradhana. Fine, yes, because your what is f of x? F of x is simply x root x when x is bigger or equal to 0 and x into root of minus x when x is less than 0. So use these expressions to confirm that function is differentiable even at 0 and the derivative is 0. F dash 0 is 0
Yes, sir.
and these derivatives can be computed simply by our usual computations and then realize that f dash is being continuous at 0. That's not a big deal. Everywhere else anyways it is going to be continuous. So f dash x you can write separately and at 0 it is 0. Say if you want to write separately, this can be done and then confirm that f dash is continuous by simply computing left side right side derivative limit of f dash as x goes to 0. So that's correct, this should work and D seems to be the answer. Is it fine? I don't want to keep solving these questions. The idea I'm interested to just convey. So we can simply go ahead. If you see other examples, other questions like 17 is can be manageable. 18 is again mean value theorem. 19 Taylor's. 20 Maclaurin means Taylor's. You should be able to get these things. 21 again uh, roles, or LMVT, whichever. 22 again you can try to see. 23 is actually limit of a sequence. 23, if you see, are you I mean, I hope you are looking at the questions. So 23rd question, if I let me also go for it. Question number 23 is simply consequence of definition. You just have to apply definition of derivative and adjust these things. Okay, so you will get that. So you're talking about f dash 3. F dash 3 is 18, right? So I mean, try to create f dash 3 expression. So f of x plus 5 by n, you can say minus f of 3 plus f of 3. Okay, and then f of x minus 2 by n minus f of n is f of 3 you add and subtract, and that will give you the, so that is the hint. I hope that is enough. So apply definition simply. Apply definition. Okay, of f dash of f dash 3. Okay, that works. Yeah. Look at 24 is geometric. You can, do you want me to answer 24, 24, 25? Try out. What will you do to handle 24? Draw. Drawing is enough. At A it is 0. At B it is 0. Your line L1 is y equal to 4 times x minus a. X minus a means it will go like this. Maybe the slope is 4. Okay. This is L1. And L2 with the similar reverse slope minus 4. It will go like this. This is L2. What will happen? Your function's slope cannot cross 4. Mod f dash. So slope is lying between minus 4. Slope of the tangent at any point is between minus 4 and 4. That means these lines kind of are the boundaries for the slope. So what do you expect the graph to remain? Can it go here outside, move and come back to B? Hmm?
No, sir.
Ah. So at least can you see A must be true? It always lie below the lines. Whatever the graph is, it has to lie below. In fact,
Y-
huh,
Yes, sir. Yes, sir.
right. Now only thing is now B is not out of question. D, what do you think? D, can D happen? Like the graph passes through this point. Can that happen? See, problem is it cannot cross the lines. So if at all it should pass either, I mean, it has to be then through these lines, but then it won't be differentiable at this point. which is not true. Understand? So it cannot pass through this point. Do you get a feel of what I'm saying? This is not true. This is obviously not true because A is true. So question is whether this is true or not. Okay, I could see some chat. C is also very good. Aradhana, you are correct. C is true. I'm disclosing, others can try it out. You can actually see that what is this intersection point? It is actually the midpoint, A plus B by 2.
Yes, sir.
And so look at the height. And then that height, if you draw a rectangle, you will realize that this is half of it. The area of the rectangle will be something like B minus A square into 2. You will get that. And so the maximum area that a function can cover will always be less than or equal to half of it. That is less than, rather strict, because this point is not attained. So strictly less than B minus A square. The area of this triangle actually is B minus A square. That is also enough for the argument. Okay. So this is also true. C is also true. Good. Yes, maximum area. Good. So I'll just move to something else. Even 25 is interesting to discuss quickly. What do you do? Tell me fast about 25. I want one or two questions on fundamental theorem. Sorry. What shall we do?
Sir, basic definition of derivative.
Yes. So what is the answer?
It's convergent.
Okay. Point is function is not given to be differentiable at 0. You understand? Function is differentiable on open 0, 1. Got it? Whereas an is converging to 0. So f of 1 by an, can we say it should converge and it should converge to f of 0? No, because we don't have f of 0 available. Yes, Aradhana, I got that. But problem is we don't have 0 in the domain. Mean value theorem is needed. It is needed, correct? So you know that f of 1 by n is Cauchy sequence. You try to look at f of 1 by n minus f of 1 by m. Okay. Now this is, you apply mean value theorem and you can say this is equal to some f dash at some tn, yeah, tnm, between 1 by n and 1 by m, mod of this into mod 1 by n minus mod 1 by m. Understood? And now this is less than 1, that is sure. So this is less than 1 by n minus 1 by m mod. So this can be made arbitrarily small because 1 by n is a Cauchy sequence. So this becomes Cauchy, right? And reals is a complete set. Hence every Cauchy sequence is convergent, and hence you got this. Okay. So little work is expected because, okay, so fine. Good. Okay, we'll do one thing. We'll move to the next page and try something. Say, let's try 34, maybe. Question number 34. Or let's try 35 first, then we'll go for. Those who are trying 34, go ahead. 35 will. Okay. Suppose I am talking about 35 first. So what is fundamental theorem of calculus? Who is telling me? There are different versions. So if I take, let f from closed AB to R be continuous function, and capital F from closed AB to R defined as f of x is equal to integral a to x ft dt, then yes, someone to complete quickly.
Capital F is differentiable on
Correct.
slope.
Capital F differentiable, and yes,
F dash of x is equal to f of x.
correct. Capital F dash is small fx for all x in the domain. This is okay. Yeah, Sunil has answered it for 35. Fine, fine. Okay, so now you apply. Now this is your capital F. Fine. So what I have is capital F of x is equal to uh, integral 0 to x ft dt. So by the theorem, you know that f dash x is small fx for all x. So if I am asked to get f of pi by 2 is same as capital F dash at pi by 2. That means you just have to get the derivative of this and evaluate it at pi by 2. That's it. Okay. So that you have to compute. I'm not going to do. And if I uh, rely on Sunil's answer, the answer is C. Whatever the answer is, you have to work out. Now, this is a trivial exercise of getting the derivative of this and compute it at pi by 2. So do that. Can you all do it?
Yes, sir.
Ah, good. So answer should, I mean, Sunil's answer is C. I don't know. I have not calculated. अब देखो क्या आता है. Now think about 34. 34 I think is from recent paper.
Sir, B is the answer.
Okay,
इसमें
fine.
B.
Hmm. So B with again Sunil's question. I mean Sunil's solution. Fine, fine. No problem. Let others work it out. Yeah, chat. I could see B, many Bs. Fine, good. Now, can you play with this quickly? 34. I wish to take it on. Okay, Arpita and Hetvi got the answers for 34 too. Fine, good. They can go ahead. Huh? Say there is 36, which you can try meanwhile. For those who are working with 34, you just, when it's up to you, you can use kind of a
It's
chain.
1.
Yeah, it's one, which is correct. Correct. Those who want, they can just simply say, and then your small fx is actually capital F intersection, composed with G, where capital Fx is integral -1 to x e raised to t square minus t dt, and work it out. So f dash is what we have to talk about because we want to see decreasing, increasing in which interval. But f dash is capital F dash at gx into g dash at x. But that is now capital F dash at x is e raised to t square minus, e raised to x square minus x. So f dash at gx is whatever it is, it's going to be positive because e raised to gx square minus gx into g dash x, that is 2x minus 2. So f dash is positive if I want. That means this is anyways always positive. So I have 2x minus 2 positive, that is x is greater than 1, right? Then f is increasing, and x less than 1, then f is decreasing. So 1 is the answer. Good. Yeah, Leibniz rule. Can use that. Radhana. Correct. I actually computed it. Yeah. Shall we look for 36? That will be the last. Oh, sorry. What is the information? Hmm. Start कहाँ से करेंगे? Can someone say something? What to apply? Just to try. एक ट्राई करने के लिए तो क्या कर सकते हैं? कैन समवन से?
Sir, form equation of line by given the points
ओके, लाइन।
and uh, and then mean value theorem.
हाँ, right, correct. Simply mean value theorem means LMBT you can apply. So this is like there is some C lying between -1 and 3 such that f dash C is f of 3 minus f of -1 upon 3 minus -1. That is 7 minus 1, 6 upon 4. So 3/2. Fine. Okay. Now what to do? We want to talk about -1, 2, 3, and so this is 0, 1, 2. Okay, let's try LMBT over this. What will that give us? So there exists some C1 between -1 and 1 such that f dash C1 is f of 1 minus f of -1 upon 1 minus 1, that is 2. Fine. That is f of 1 minus f of -1 is 1 upon 2. Okay. And there is another one, C2 between 1 to 3. I'm just trying. I mean, even I'm f dash C2 is, see, why am I intended to try this? Because at least this involves f of 1, which I want to compute. Okay, so this may help. So let's see. F of 3 minus f of 1 upon 3 minus 1 is 2. That is f of 3 is now known. So 7 minus f of 1 upon 2. Okay. Now what to do? Hmm. So you see f1 minus 1 upon 2 has to be less than or equal to 3/2, and 7 minus f1 by 2 also must be less than or equal to 3/2. Do you agree to this? Okay, people have already got the answer. 6, 4. Okay, correct. Okay, I think I am the one who is getting last. Is this the method you applied or something else? Here, distance between -1 and 1 is 2 units. It is nice that you have guessed it. Means I'm so for me, I'm just doing some hard work, it seems. And 7 minus f of 1 is less or equal to 3.
Sir, one time you get 4 less than 4 and one time you get greater than 4. So it means it is equal to
It is
4.
equal to 4, correct. So this method only everybody did, right? Yeah. Then it is fine. So I thought I'm using some. Uh, yes, Aradhana, maximum increase is 2 into 3 by 2. Fine. Ah, ah, good. So ultimately f of 1 is 4, which is correct. Fine. I just would like to wind up, but wanted to mention this quote which I liked. One has to perceive, then only we'll be enjoying. And I'm sure everybody in this group is doesn't need, they have actually experienced this. So keep solving more problems. All the best to everyone. I think I can wind up now. Okay, so all the best everybody for jam. Hmm, I'll stop sharing my screen. This sheet I have already shared, but I'll share with the organizers also so that it can be passed on to everybody. And I'm not going to share the solutions, okay, because of two reasons. One is, then people, once, sometimes it's a human nature, you stop, uh, you try to converge to that answer somehow. And secondly, one should be confident about his or her answer. So as a practice it is better. Still, if anyone has any doubt, you can, my email id is available, mandar.khasnis@gmail.com, and you write the solution and then send me if you want me to check. Okay. Yes, let's stop. Once again thanks the organizers,
Thank you, sir.
okay,
Yes, sir.
for such opportunity. Thanks.
Thank you. I take this opportunity to thank Mandar sir. Well, he was one of the first few who agreed. The moment the time we told him about this idea, he was one of the few who was on board with this. And sir, thank you so much for the valuable inputs you gave throughout for guiding us.
Yeah,
Thank
my
you.
pleasure.
And we look forward to more such sessions from you.
Yeah,
I
yeah,
hope
sure,
the
sure.
students have benefited, and I request the participants to please fill the feedback form so that we get to know what improvements we can make in the if we organize such workshops again.
Yes, yes.
So once again, thank you so much for coming.
Yeah.
Thank you, sir.
Thanks. Bye bye.
Bye.
I'll just wait because people are still messaging.
Yes, sir.
Aradhana is from where? Okay, Mumbai. Which college? Acha, Junjunwala. Yeah, Kalairasi. Kalairasi is from which state? Pondicherry. Okay. Nice. Okay. So bye everyone. I'll make a move. Chalo.
Yes, bye.
Yeah. Bye. Bhavad Dharani. Yes. Yes, thanks.